All right, so this video that I'm making right here is a help video, like a guide for you to complete your lab number 5, which is on global climate. So officially this lab was created by the Department of Geography from the University of Idaho, but it has been highly modified by CWI staff. Melissa Schlegel was the first one to modify it, and then Gabriella Boylan, have changed it since then also. So let's go ahead and get started. So climate is defined as the typical conditions for a location, determined by calculating averages of weather observations over time. That's important. So determined by calculating averages of weather observations over time. The climate for a region is controlled by many factors, including latitude, elevation, ocean circulation, local topography, and prevailing winds. The climate for any given location has changed considerably over the last 4.6 billion years, which is how old the Earth is. And it's still changing. So we measure these changes by looking at trends in paleontological proxy records, since we didn't have enough ways to record these temperatures before, right? In this exercise that we're going to be doing today, you will explore the distribution of climate regimes across the Earth's surface. You will also make observations about climate trends from tree ring cores. So you will have the first section, we're going to do basically on current temperature data, we're going to do some analysis. The second section, we're going to do some tree ring cores. We're going to use them as proxy records. And then the third bit, we're going to look at the ice core records as well, also as proxy temperature records or paleontological proxy records. So it will be pretty cool. So I'm going to skip through the goals. The equipment that you require are, you need a ruler, you need a calculator, and you need computer with internet access, and probably a printer. You don't necessarily need it. You can do it still through your, just zooming in basically, but it's helpful if you have a printer, from what I recommend. However, you do need a ruler for sure, and a calculator at the very least. Excel would be useful instead of a calculator, but if you want to use your calculator, that is perfectly fine as well. Alright, so the first part, calculating climate. So climate is determined by a variety of global factors, but it is observed through the day-to-day collection of weather information and subsequent analysis of that information. If you watch the weather on TV or look for weather forecasts on the internet, and the forecast says it is going to be, let's say, 5 degrees hotter than normal or drier than normal for the month, the forecast is using a very careful calculated version of what normal refers to. So this version of normal depends on how many years of data are being analyzed and where the weather recording stations are located that contribute to that dataset. For example, while there is a weather recording station on campus, the nearest one used by the National Weather Service, which provides the official reading for the area, is at the Pullman-Moscow Regional Airport. Again, remember that this was done at the University of Idaho, which is in Moscow, Idaho. So that is why they refer to campus as U of I, okay? So, again, the nearest recording station that the National Weather Service uses is at the airport, Pullman-Moscow Airport, which is 7 miles away from campus itself. So, the map that you have here shows 2 local weather recording stations, one in the Pullman-Moscow Airport, as you're seeing here, and then the other one at Lewiston Airport, so right here. Most official U.S. weather recording stations are at airports or remote locations in the mountains. They're typically not in populated suburbs or rural areas because these tend to change temperatures pretty highly. So actually here in the Treasure Valley, the Boise Airport also has the main recording station that we use for these type of observations. So instead, weather forecasters use the closest stations and calculate the predicted conditions between them. You might observe consistently different weather at your house than what the National Weather Services on your local weatherman reports for your area say. And again, this has to do based on the location where their recording station is at. Okay, so on the following page, there is going to be a table. So here is that table. On the left part of the table is a record of the daily high temperatures recorded for a single month. That month is June of 2008 for both Pullman Airport and Lewiston Airport weather stations. Okay? On the right part of the table is going to be a record of the average high temperatures for each June from 1990 till 2019. So that's 30 years of data for each of those stations. But the 2008 station June data average is missing. So what you have to do, we'll follow next. So once you know the average June 2008 temperature for each station, you can determine the normal June temperature for each station by calculating the average of 30 years of monthly averages. So how will you find the average June 2008 temperature? Is by calculating the average high temperatures of the June 2008 for each of those stations. So let me show you that table so you know what I refer to. So again, this left part of the table has the days of June, which is 1 through 30. And then you have temperatures recorded both at Pullman and at Lewiston airports for each of those days. So those are the average temperatures of the day for either of those stations. And then here at the bottom, you have a highlighted area where you should fill in the average temperatures for all of those 30 years at either station. So the easiest way, in my eyes, to do this is by using Excel, but you can just use your phone calculator or any other calculator and do this. So hopefully you know that averages are just going to be basically the summation of values that you have divided by the number of values that you have. So we're going to go ahead and do that. I'll help you with the first station, so Pullman. So day 1, let's see, 67, and you can input all of these, right? 56, 59, 54, 58. I'm just going to do 10, all right? 65, 64, 46. So ideally, you will continue to do this until day 40. Oh, I skipped one, I think. Let's see. 46, 64, 58. What did I skip? 54, 59, 56. Oh, another 56. Okay. So you will continue again doing this until the 30-day mark. And then once you have that, you say, all right, you will have this. So this is going to be the summation. Hello. Of all of those values, yes. Okay, and then I want the average to actually, and you can actually do average in Excel. So let's undo that. I want to do average. But let's do both. So that's the summation. And then to do the average, you would say the value, that summation divided by, in my case, I only input 10 values. So in my case, it's going to be over 10. And that's the average of temperatures from days 1 through 10 of June of 2008. I can do here an average, just so you know how to do it. On Excel, you put average, maybe. And then again, I don't want all of those values. I want them until A2 through A11. Oh, through A11. Excellent. All right. And as you see, both of these values are the same because that's just what an average is. Great. So again, what you have to do is do this, but for all of the values of the June temperatures on either one of those stations. Okay, so again, you do that for both of the stations for all 30 days of June 2008. And then once you have those averages recorded, you put them here on the bottom as your average for either one of those. That same number that you obtain is going to be the number that you input here. And later, as you see in the instructions, what you will do is fill in that missing June 2008 average temperature in the 30-year table on the right. So that is basically placing that average here. And then you will calculate the average high temperature for June over 30 years from 1990 to 2019 for each station. So same thing, you would basically use Excel and basically input the values that you have. Let me do this. That you have for all June average temperatures from 1990 until 2019. So that's the first one in 1990, then 67, 79, 70, 74, 69, 72, 68, 70, 67, so on and so forth. So you will do the same thing here at the bottom. You will simply say average for B for those values, and then you come up with an average. Again, this average that I just obtained is the one from years 1990 until 1990 until 1999. Yours will be all the way till 2019, okay? And in the value for 2008, you use whatever average you obtained here at the bottom from the previous calculation you made. Okay, so hopefully that's straightforward. I don't think it's too hard. It will just take you a little bit of time to get those numbers, but it's not too complicated. If you need help, let me know. So whatever resulting averages you obtain for all June temperatures at both stations from 1990 on to 2019, you record here at the bottom of the table, bottom right of the table. Okay, second question. So for Pullman, was June 2008 warmer or cooler than normal? So what was that difference? So basically, you will find this temperature, right, of June 2008, and you will compare that temperature to the average that you obtain here on the bottom right. So you will be able to see whether or not that is warmer or cooler than the average of those 30 years, and you'll be able to tell me what the difference in temperature is. Okay, third. For Lewiston, was June 2008 warmer or cooler than normal, and what was the difference? Same thing, but in this case you won't use the Pullman temperatures, but rather the Lewiston temperatures. Alright, number 4. From a climate perspective, how much warmer is Lewiston than Pullman in June? So again, remember, from a climate perspective means that you are looking at many years of observation, the average of many years of observation. So you will be using the numbers that you obtain here on the bottom right side rather than the ones you obtained here, because these are just the ones from 1 year. These are the average ones for several years, or more than several, I should say, many years. So it's on a climate perspective. Number 5. Why do you think this normal temperature difference between the two cities exists? So in this case, I will point back to the beginning of the lab where I give this little idea, and you can think about where Lewiston is relative to Pullman. So you might have to do a little bit of consultation if you haven't been there, but think about, again, things like, like latitude, elevation, ocean circulation. In this case, ocean circulation won't be a difference because they're both pretty much in the same longitude and far away enough from the ocean that that's not going to make too much of a difference. Local topography and prevailing winds. So think about those things, and again, maybe you'll have to look at a map of them and perhaps look up some facts about where they are located, and you'll be able to answer that question. Okay, so the Pullman Airport is at an elevation of 25-45 feet of elevation, while the Lewiston Airport is at 1477 feet of elevation. Kendrick, Idaho is at an equal distance from each station and has an elevation of 1401. So from this map, Kendrick is right here. So the distance is about the same from Pullman than from Lewiston. However, the elevation is much closer to the elevation of Lewiston than it is to the elevation of Pullman. So do you think that Kendrick is climatically more like Pullman or more like Lewiston? And why is that? So I'll let you think about that.